Yes, ma'am.
Omkar. Okay. Then Arti, Parth, Wanderson, Junaid.
Yes, ma'am. Yes, ma'am.
IS 800 कॉपी आहे आता सोबत?
Yes, ma'am.
Okay.
Yes, ma'am.
So all of you now open page number 18 of IS 800 2007. IS 800 2007 is to be used, not 1984. So I'm also showing the same copy right now here. Okay, page number 18. Is it visible to everybody?
Yes, ma'am, it's visible.
Okay. So IS 800 table 2, limiting width to thickness ratio. We have to refer this table now. We will discuss about this table first. Now in this table, the various compression elements are given. Their description is given. Then this ratio is actually the width to thickness ratio. So width of the various components of a given section, various parts of the section, and its thickness, its ratio is defined here. Okay. Now these B by TF, D by TW, all these notations are given on the next page, that is on page number 19, through these various diagrams. So whenever we have to refer the table, we have to consider the diagrams also, or it's vice versa. When we refer a diagram, we have to refer the values from the table. Then the next column, column number 3, represents the limiting value for this ratio. Okay, when the value of this ratio is less than 9.4 epsilon, the section or the given part of the section is classified as plastic. If it is in between 9.4 epsilon to 10.5 epsilon, it is classified as compact. When it is in between 10.5 to 15.7, that is greater than 10.5 epsilon and less than 15.7 epsilon, the same part it will be classified as semi-compact. And if the ratio is greater than 15.7 epsilon, the part will be classified as slender. Okay, so if any particular section is showing, any part is showing the class of a section as slender, we should reject that section. When we start the design and when we select a section from steel table, we have to find out the class of the section. Class of the section actually defines the moment carrying capacity or the axial load carrying capacity of the section without showing local buckling. Okay, so if a section is not having a capacity to carry the moment or axial load, and even before yielding a single fiber of the section, if a section is getting failed due to local buckling, such sections should not be used in the construction. Okay, so these sections are slender, and the other three types we have already discussed, that the plastic sections are the sections which carry the moment equal to the plastic moment, and the sections have a capacity to develop plastic hinges, and the rotation at the plastic hinge also takes place, and then the section fails. Okay, so plastic sections are termed to be, or these are nothing but the strongest section, whereas the compact section, it has a capacity to develop the plastic moment, but it is not able to rotate. The plastic hinges are formed, but the section is not able to rotate about those hinges. Before that only, the section will fail due to buckling. Okay, because the ratio of width to thickness ratio is small. So these sections are called compact sections. So these are also strong, but not as equal to plastic section. But compact sections are stronger than semi-compact. Semi-compact are those sections in which the yielding moment is developed. That is, the section has a capacity to carry the yield moment. But beyond that, when we apply a loading, the section fails due to buckling. So it doesn't have any capacity to develop plastic moment. It has, or the stresses developed in that section is limited to Fy only. The stress distribution diagram corresponding to all these classes also we discussed in the last lecture. Now today we will focus on the values. So is it clear to everybody how to use this first row? I have just explained. Now whatever the D by TF value or D by TW value we calculate, We compare with these values given in the table, and depending upon that, we decide the class of a particular section or a part of a particular section. Now coming to the first column. First column gives the description of various parts of the section. Now, first value or first explanation is outstanding element of compression flange. It means a flange which is in compression and its outstanding element only. Now, last time we also discussed the types of element as the stiffen element or unstiffen element or outstanding element or internal element. Okay, unstiffen elements are called as outstanding, stiffen elements are called as internal element. So if I go to this diagram of I section, now in this I section, we know there are two flanges, top and bottom. So any flange will be in compression depending upon how we are applying a load. If a section is used as a beam and a load is acting vertically downward, the top flange will be in compression and bottom flange will be in tension. If the same section is used as a column, the entire section will be subjected to axial compression. So each and every part of this I section, either it is the top flange, bottom flange, or the web portion, all these three parts will be in axial compression only. Okay, so the explanation what is given here, outstanding element of compression flange. So we have to consider only the flange part, not a web. And in this flange, this part or this part is an outstanding part. Okay, the same width of that outstanding element is denoted by B here. So it is a half of the total width of the I section. So this part or this part is nothing but the outstanding element of I section. Coming to the channel section, now if you consider the different sections available in the market, there are only three sections which has flange. First is the I section, second is channel section, and third is the T section. So out of these three, whatever is the section you are using, depending upon that, you have to consider the outstanding element of the flange. Okay, so in case of I section, this is the outstanding element. For channel, this is the outstanding element. In case of channel, the entire width of the channel is the outstanding element. It is considered in the full width of the channel is considered in the calculation. And in case of T section, again the half width is considered as the outstanding element. Okay, so you must know what is the outstanding element of a given section, which part we deal or we consider as outstanding element, and flange. It is of flange. It is clearly mentioned that it is from the compression flange. Okay, now for this selected part of the section, again there are two types, rolled section or welded section. Now rolled section means, if we go back to this diagram, all these are nothing but the roll section. So row number 1 and 2, all these sections are rolled section. Whereas if you go to the row number 3, these are the sections, all these are the welded. Because this is a I section again, but it is formed by welding three different plates. Okay, two plates as a flange and one plate as a web. So this is also called as a built up section, or it is called as a welded section. Okay, so all these three are the examples of welded section. I think in your current syllabus, welded section, you will not require to design, but obviously in practice, when we go for the deep beams, then we need to go for such welded sections. Okay, so such beams are used for built up sections, built up columns, or these may be used for a plate girders. Okay, or even for gantry girders. So these are nothing but the welded sections or built up section. So design of all these is not completely included in your syllabus right now, so you will not require this right now for this particular subject. Now, so for your calculations, you have to refer the first row values always, depending upon which section you select. And then you find out the B by TF value. Now use B given in the diagram, corresponding diagram, TF given in the corresponding diagram of page number 19. Okay? Any doubts in this?
No,
No,
ma'am.
ma'am.
No,
Huh. Okay, fine. Now coming to the next row, that is internal element of compression flange. Now if I will go back to these diagrams, I, C and T section. Okay. Now in I, C and T section, the flange portion we have already seen, and there is no any internal element in flange. What is the meaning of internal element? The element which is having support in at both the edges. In case of the I section, if we consider the outstanding part, it has a support at one end and the another end is free. Okay, for channel also it has a support at one end, another end is free. In case of T also, half width when we consider, at one end it is supported, another end is free. So there is no any internal element present in the flange for these three sections: I section, channel section, T section. So that particular clause or row is not applicable for these three sections. Now, which is the section for which that sentence is applicable? It is nothing but your box section. Okay. In case of a box section, there are two flanges and two webs. Okay. So top flange and bottom flange, if you consider the support system given for this flange, both the edges are supported. So the top and bottom flange, or the one which is in compression, will be the internal element. So that row description is applicable for hollow rectangular section only. If you come down to the built up sections, here now, if you consider this built up section, that statement is applicable for this flange, because this flange is supported at the another edge also. Okay, here this is a welded box section, so it is applicable for the flange of box section also. Is it clear? Internal element of compression flange.
Ma'am, but in the case of a box,
Huh.
all the four edges are connected. Then they
Sorry,
all should be
sorry.
the internal elements.
Your voice is breaking, Omkar.
I mean, case of the box section, ma'am,
Huh?
all the four edges are connected.
Hmm.
So we should say that the all are internal elements. No?
Yes, correct. Correct. But suppose the same section you have used as a beam section. All the parts will not be always in the compression, right? So if this section is used as a beam, the top flange will be in compression zone, bottom will be in tension zone, right? So we are considering only the compression part, the part which is subjected to compression action. Okay, so this concept of section classification, or I would say the buckling, local buckling phenomenon, is more vulnerable in case of the sections which are subjected to axial compression. If the member is subjected to axial tension, we don't need to check even the section classification. Okay, only we have to check whether the section is not slender, whether it is slender or not. If it is slender, then we should reject it. If other than slender, any type or class of the section we are getting, it will be completely safe in case of tensile member. But in case of compression, normally we should go for the plastic section or compact section as far as possible. Okay, so for columns and beams, we always go for I and channel section. Why we don't go for angle section? Because all the angle sections available in the market, they are either semi-compact or slender. When you find out the problems, when you solve the problems based on calculation part, or when for given any particular angle section, when you find out its class, you will come to know that all the angle sections are either slender or semi-compact. Okay, so for columns and beams, we never use angle section. We always go for, unless and until the load is very small. If the load is very small, then we can use angle section. But if there is a heavy load, then we never go for angle section. Okay, we either use I section or channel section. Is it clear? Now for box section, the top flange and bottom flange, both the parts are considered as the internal element. Web also, it is internal element. Okay, but for calculation of web, we have a different formula because it has a different thick depth. We do not indicate its this dimension as width. We call it as depth. Okay, and this is its ratio is given in a different row. We will come to that row soon. Okay, now let me finish this. Internal element of compression flange. Again, there are two types: compression due to bending, and second is axial compression. Now in the section, the compression will get developed due to bending when we are using a section as a beam. Okay, beam, when we subject it to the vertical downward load or vertical upward load, it will bend. And because of this bending, some portion will be in compression and some portion of the section will be in tension, either above the neutral axis or below the neutral axis, depending on how the load is acting, the direction of the load. Okay, so compression due to bending means when you are using a section for beam, you have to refer these values given in the row. Okay, whereas if the same section you are using as a column, in case of column, all the parts of the section will be in compression. So columns are always subjected to axial compression. Now, the column may be subjected to bending also along with the compression when it has to carry the eccentric loading. Okay, so along with the axial force, the moment is also acting on the column. In that case, then there will be bending in the column. So in that case, we can use the first row. But most of the time for column, we design it as axial compression and we refer the values given in the second row. Now, in the second row, if you observe, B by TF ratio for plastic and compact, it is clearly written not applicable. So there is one criteria only. Either the section is less than 42 epsilon, not section, the ratio, or the ratio is greater than 42 epsilon. So when it is less than 42 epsilon, the part is semi-compact. When it is greater, it is slender. So when we consider internal element of compression flange under purely axial compression, we either get a section as semi-compact or slender. Okay, so see if you can observe these two diagrams or three diagrams, say I section, channel section, and rectangular hollow. Obviously, simply by observing this diagram, we can say that of course I section will have a more load carrying capacity as compared to rectangular hollow section, because it is hollow, and it is more susceptible to buckling than the rectangular I sections or channel section. Okay, buckling means not the entire, a single part of the section also when it buckles, we consider that failure of the entire section. Because buckling of one part, when it takes place, these additional stresses are developed in that part, and that part will get weaken and weaken whenever we go on increasing the load on that entire section. Okay, so a small part of a section, when it shows buckling, we consider a failure of the entire section. Is it clear? Omkar, your doubt?
Yes, ma'am.
Huh. Now coming to the next part, we have discussed about the flanges of the eye and channel section. Now we'll come to the web of an eye, H or box section. So for eye section, for channel section, for box section, for T section, H sections are not shown here in this diagram. Okay, for all these, the web, this web, its depth D or H, it is denoted in the diagram. Accordingly, you have to choose the appropriate value and you need to find out that ratio. Okay, so for web of an eye section, H section or box section, again, there are three cases. One is the neutral axis at mid depth. Second is generally if R1 is negative, R1 is positive. And third is axial compression. So for beam, when the section is to be used as a beam, we have to refer the first row. Last row, when we have to use the same section as a column. Now, when the neutral axis is not at the mid depth, at the mid depth, R1 values, either we get it negative or positive. So how to find out R1? It is given below this table. Note number 5. The stress ratio R1 and R2 are defined as actual average axial stress, negative if tensile, and design compressive divided by design compressive stress of web alone. Okay, now these values we can calculate only when we know the stresses developed in the various parts of the section. Okay, so this type of calculation we rarely use in the design. We always consider that neutral axis is at mid depth and we go for the first row only. Otherwise, we need to calculate the stresses. Then we have to locate the neutral axis, depth of our neutral axis, and accordingly we need to do the calculation. So that becomes complicated. So practically we do not use these values. We use either the top one, the neutral axis at mid depth, when the section is used as beam, and when the same section is being used as column, we use axial compression. Okay, so now by observing these three rows, when we want to find out the section classification for I section, we have to find out the class of web separately, class of the flange separately. Okay, because the values are given different. For compression flange, it is the ratio is different, the values are different. For web of an I section, again, the values are different. Value means these values, limiting values. So it is always possible that the different parts of a section are showing different class. For example, for given I section, the flange of a section may be plastic, whereas the web of a section may be semi-compact. Okay, so different part of the section are showing different classification. The combined class of that section will be the weakest one. Weakest one means what? Or the same is written here. Different elements, see the point number 4 in a note, different elements of a cross section can be in different classes. In such cases, the section is classified based on the least favorable classification. Now, as we have considered one example, in case of a given I section, if a flange is plastic and web is semi-compact, the overall class of the section will be semi-compact, because for a given I section, web is weak as compared to the flange. So when we apply a load on this section, the web will fail first because it is semi-compact. It has a capacity to develop the yield moment only. And if we increase the load beyond that, the moment carrying capacity of a web is not sufficient and it will buckle, even though the flanges are having a capacity to develop the plastic moment. Okay, so the class of the entire section is considered based on the least favorable classification. So in that case, the entire I section will be classified as semi-compact and the calculations are done based on that. See, when we design any given section for a compression, axial compression, either a member of a truss or a column, we need to find out this section classification first. And depending on upon the class of the section, the formulas for calculation of moment changes, the criteria changes. Okay, so this is very important point, very crucial point in case of the compression member. Tension member, there is no issue, because when we apply axial tension, and if we know already that the force in a given section will be always tension, like in case of cables. Okay, cables are always subjected to axial tension. So if we know already that the section is going to be carrying always a axial tensile force, there is no need to check the section classification. Only we have to check whether our selected section whether it is slender or not. If it is slender, we have to reject it. If it is plastic, compact, semi-compact, the formulas will not change in case of tension member. But in case of compression member, the formulas are different for depending upon the class of the section. Okay, guys, is it clear? Now we have discussed about I, channel, and T section. Now here you can see web of an I, H, and box section. Below it, immediately it is given as web of a channel section. So for web of a channel, we have to refer this row. Then next, angle section. Now angle section, again, as I discussed earlier, we can use the section as a axial compression member, or we can use the section as a beam or as a column. Axial compression means I have considered three cases here. One is the strut member, a member of a truss, which is always subjected to axial compression. Okay, this angle section, if we are using as a column, very rarely we use it as a column. When a load coming on the structure are very less, like say cycle stand or a bus stand, for the such shades, the columns are made by angle section, because the load coming on that such shades are of very low magnitude. Okay, nobody is going to climb on that. There will be no any high wind force or lateral forces acting on the entire structure. So there we can go for a economical section like angle section as a column section. Okay, and the angle sections are also being used as a beam section. If you consider the example of a purlin, in case of industrial shade, many of the time the purlins of angle sections are used. Okay, again, this is depending upon the height of the structure. If height of the structure is lower, the wind intensity is very small, we can use angle section as a purlin, which is designed as a beam. Okay, so for an angle, when there is a compression due to bending, it means the angle section is being used as a beam. Then we have to use these values. Okay, we have to find out B by T and D by T. So let us see what is B and D in case of angle section. For angle section, this is D and this is B. Now, right now in this diagram, you can observe that it is an equal angle section. That is D and B both are equal. But we have unequal angle section also, in which the D is more and B is small. Okay, so in that case, whatever is the dimension, that appropriate dimension we have to use to find out the values. That's why the two values are given, because two legs, they may not be equal in dimension. Thickness, normally it is same for both the legs, but the width of the leg varies, and that's why we get two types in angle section: equal and unequal angle section. Then in case of single angle section or double angles with the components separated, axial compression, it means if a single or double angle sections we are using for column, axial compression for column or as a compression member. Now double angles with components separated, it means, refer this diagram now. This is a diagram. This is a double angle section which is connected back to back, and separated means for connection we have to use the gusset plates. Okay, the gusset plate is provided in between the two angle section and these are connected together. So these are separated. Okay, so this is the example of a double angle section. Now the next row is outstanding leg of an angle in contact back to back in double angle member. So now outstanding leg means this leg. This is a double angle which are in contact, but in contact there is only one leg. If you consider this as one angle and this as the second angle, from the first angle one leg is connected with the second angle one leg. Okay, so these two legs are in contact, whereas these two legs are not in contact. They are not touching to each other, or they are not connected, in another word. So these are called as outstanding element. Okay, so in case of double angle section, outstanding leg of an angle in contact back to back in double angle member. That value you have to consider for calculation. That means this leg, the dimension of this leg you have to consider for calculation. Next is outstanding leg of an angle with its back in continuous contact with another component. So this is applicable for single angle only, and this is applicable for the double angle sections. Then stem of a T section, rolled or cut from a rolled I or H section. Stem of T section means this is called as stem of T section. So in case of the T, as we discussed in last lecture, that all the members are your unstiffened elements, right? Flange is also having a support at one end, another end is free. Similarly for stem also, one end is having support, another end is free. But this portion, it is not identified as a web, but it is identified as a stem of a T section. And for that, the formulas are applicable over here. Okay, so this is D by TF. And the last is circular hollow tube, including welded tube subjected to moment and axial compression. So beam and for column, the values are given separately. Is it clear, guys, how we have to make use of this table along with the diagrams given on the next page? Is it clear?
Yes, ma'am.
Okay.
Yes, ma'am.
Now let us read the notes given below this table. First one is elements with which exceed semi-compact limits are to be taken as of slender cross section. This we already discussed. What is epsilon? Now, in all these formulas, we can find out one term epsilon. Epsilon is defined as 250 divided by Fy under root. Now, this value we always get as 1 because the steel which we use as a structural component for any structure, it has Fy value always equal to 250. Okay, Fu is 410 and Fy is 250. This is fixed for all type of sections which are being used as a structural member. Okay, this is clearly defined. We have already discussed this in this code also it is given. I will go back to the this table, see the table number 1 in which we have already discussed that, or I will go to the statement where it is written. See here on page number 12, clause number 2.2.2, all the structural steel used in general construction coming under the purview of this standard shall before fabrication conform to IS 2062. And what IS 2062 says, it is given in table 1 on page number 14. See IS 2062, the yield value, Fy value is 250 for all the 3 types of the section. Okay, so we are using E250, this grade of the steel for as a structural steel. Okay, is it clear? Is it clear, guys?
Yes, ma'am.
Yes, ma'am.
Next, web shall be checked for shear buckling in accordance with 842 when d by t is greater than 67 epsilon, where b is the width of the element, may be taken as clear distance between lateral supports or between lateral support and free edge as appropriate. T is the thickness of the element, d is the depth of the web, d is the outer diameter of the element. Now, this clause is applicable for plate girders. Okay, so when we learn the plate girder, you will understand what is the meaning of this statement. Okay, and fourth and fifth we have already read. So is it clear? Any doubts in this? Because we are going to solve now problems. Any doubts? आज काय बोलायची तयारी दिसत नाही कोणाची.
No doubts, ma'am.
Okay, write down the problem statement. Find out the section classification for following sections. Are you writing?
Yes, ma'am.
Write down the section, find out the section classification for the following sections. Write down the first one, ISLB 450, ISLB 450 at 65.3 kg per meter, at 65.3 kg per meter. So for this section, now we are going to find out the class of the section.
मॅम सेक्शन कोणते?
सांगितलं ना मी आता, ISLB.
मॅम आवाज कट झाला.
Okay. Wait a minute. I will write down and you will find out. Wait a minute. I hope everybody is having the steel table also.
Yes, ma'am.
Can you see the word file?
Yes, ma'am.
Yes, ma'am.
So let me write down now the section. It is ISLB, ISLB, Indian Standard Lightweight Beam, 450, about 65.3 kg per meter. Okay. Now this section you have to find out in steel table. I will open now the steel table, the copy which I got from the internet, the scanned copy. But as I have told, you have to refer the or you have to purchase the steel table written by Ramamrutham. I'm giving you the name of the author, Ramamrutham. So ISLB, now this is the steel table in which I am referring the various I sections. Okay, so this is I section and ISLB 450. So let us find out that row. ISLB 450. Can you find out this? Can you see this?
Yes, ma'am.
Hmm. So ISLB 450, 65.3 kg per meter. This is the weight. I will little bit go up. This is the weight. First row indicates weight in kg per meter. Second indicate weight in Newton per meter. Third column gives the values of cross-sectional area. Fourth gives the depth of the section. Now the depth of the section already included in its notation. Say for example, first one ISJB 150 indicates its overall depth. Okay. Then next is width of the flange, B. Third is thickness of the flange. Next is thickness of the web. Okay, so these values we will require for the calculation. So let us write down these values by referring the code, the steel table, ISLB 450. So this is the row ISLB 450. So tell me the B value, width. This is the total width of the section, 170. Then this is the thickness of the flange and this is the thickness of the web. So just tell me these values. I will write down here. So B, let me write down the B value, or I will simply write down BF here. BF will represent the overall width of the flange. So what is this value?
170
170 unit सांगायचं न विसरता.
mm.
Then TF, thickness of the flange,
13.4 mm.
13.4 mm. We will require TW also, thickness of the web,
8.6 mm.
8.6 mm. And we will require the depth of the web also. See, if I will refer the code here, I will refer the code here. For finding the class of I section, I have to use two values. One is the outstanding element of compression flange and next is web of an I. Okay, now in web of the I, this D value I have to refer, D by TW ratio. So D value is shown over here. Now this D value is not the overall depth of the section. Okay, it is just the depth of the web of the I section. Okay, that value is not given in the steel table. Okay, this is the steel table, and in this table we cannot find out this value directly. Okay, the overall depth is given H, or if you go to the next page of the steel table, you can find out here H1 value. H1 value actually represents the depth of the web. Now, but this H1 value is considered only that part to which we can connect the another member. Now, when beam to beam connection is considered, one beam is connected with the another beam, these are connected at web level only. So that total depth H1 you can directly consider in the calculation. Okay, there are other two ways also to calculate the overall depth. The one is the depth of the web. The one is consider the overall depth of the section and then reduce the thickness of the flange, and then you need to also reduce this curved portion. That curved portion is called as root radius. Okay, root radius or radius at root, which is given as R1. So in that case, the formula becomes, see, I will just write down the formula for D here. So D is given as overall depth D minus 2 times the thickness, because there are two flanges, minus 2 times the R1. R1 is the root radius. Okay, I will write down R1 as radius at root. This value you can find out from steel table. So either use this formula, or you can use the formula as simply H1. Okay, in some books you will not find this term considered in the calculation. Some books gives the depth or calculate the depth of the I section simply by overall depth minus 2 times the thickness. Okay, so the formulae, these are different book to book. Better for your calculation, if you consider a simple value, better to use this value because it is directly given in the steel table. You can directly refer that value. If you consider this value through calculation, it is coming close to H1. Okay, so you can directly use H1 value here. So I'm just writing here D as equal to H1. Now tell me the value of H1.
384 mm.
384 mm. Okay. Now let us find out the section classification. So we will start with the first element, that is outstanding element of compression flange. Okay, flange spelling अर्धवट okay. Outstanding element of compression flange. So what is the ratio? I will go to the IS code. For compression flange, outstanding element of compression flange for rolled section, my ratio is B by TF. And B value, if I will refer, or TF value I will refer in this diagram, B is half the width of the total flange width. Okay, so B is actually BF by 2. And TF is the thickness of the flange. So I will write down that ratio first here. I have to consider the ratio as B by TF. Okay, so I will simply consider B as BF by 2 divided by TF. Okay, so let us put the values now. What is BF value? It is 170. See, I will go to the steel table and I will show you the diagram. So in this diagram, what is B? B is the full width. Okay, width of the flange. It is also denoted by B, but for sake of simplicity or for understanding, I have written the same value as BF because there will be confusion between two B value. In the diagram of IS 800, also the B values or the half the width of the flange is denoted by same notation B. And in the steel table, the full width is denoted by notation B. So don't get confused with this. See, from last 8 years, I am teaching this subject, and every year I find out almost 30 to 40% students are making this mistake in calculation. So they are getting confused between B value and they are using the full width for calculation. Then their section classification goes wrong. That calculation goes wrong. And further all calculation goes wrong. Okay, so this is very important to understand the difference between the notations used in two different booklets. One is steel table and another is the IS 800. Okay, so now BF value is 170, right? So 170 divided by 2 divided by TF value, it is 13.4. So this is 13.4. Tell me the value.
6.34.
6.34. Okay. Now we have to compare this value with the epsilon one. Epsilon, sorry, not epsilon, with the ratios given in the table. in the table number 2 of IS 800. So B by TF value, if it is less than 9.4 epsilon, the class of the section, not section, the flange is plastic. So we are calculating actually the flange or the class of the flange. We are finding the class of the flange only right now. So the value is coming as 6.34. It is less than 9.4 epsilon. Epsilon value is equal to under root 250 upon Fy. Our Fy value is also 250. So this value is coming equal to 1. Okay, so 6.34 is less than 9.4. So flange is plastic. Is it clear? Any doubt?
No, ma'am.
Are you writing, everybody?
Yes, ma'am.
Yes, ma'am.
So flange is plastic. Now let us come to the web of an eye section. So next point we have to write down web of an eye section. Okay, going to IS code, web of an eye section. We will consider neutral axis at mid depth and axial compression, both these cases, because we are finding the overall class of the section. The section may be used as a beam or it may be used as a column also. Okay, so here I will write down both now. First one, neutral axis at mid depth. Okay, neutral axis at mid depth. For that, what is the ratio? D by TW. So I will write down here D by TW. Now what is D now? The value? What is D?
384.
384.
384 divided by TW?
8.6.
8.6. Tell me the value.
44.65.
44.65. Now let us compare this value with the given limits. Neutral axis at mid depth, this value we are getting 45. It is less than 84 epsilon. So let us write down that this is less than 84 epsilon. So web is plastic. Class is plastic. Okay. So web is plastic. Now the second case, axial compression. Second case is axial compression. See, when you know or when you design a beam, you know that you are designing it for beam. So whatever the section you select, we already know that we are going to use that section as a beam. So in that case, this calculation you can skip. Okay, there is no need to show this calculation because we are not using the section as a column. When you are using the section as a column, you can skip the first one because we know that we are using it as a column. We are not using it as a beam. Okay, so in this fashion, you can reduce your calculation time in examination. So for axial compression, again, let us go to the code and let us check the ratio. It is again D by TW only. So your value will remain the same. D by TW, which we have already calculated, which is 44.65. Okay. Now, comparing this value to the given limits, axial compression 44.65 not applicable over here. Here, the limiting value is 42 epsilon and our value is 44.65. Okay, so 44.65, it is greater than 42. This value is greater than 42 epsilon. So what is the class of the web?
It is a slender.
Correct. Web is slender. Okay. Now when we consider both the parts of a given section section has flange and web. So when we consider the combined effect, let us see now what is happening. Flange is plastic, and when a section is being used as a beam, the web is plastic. So overall class of the section for beam is plastic. Okay, but when we consider the web as under axial compression, the web is slender. So in that case, when the I section is being used as a column, your flange is plastic, web is slender. So overall class of the section will be slender. We have to consider the least favorable condition. Okay, so sorry. So when you write down your final answer, you are supposed to write down in this fashion. So you just write down when ISLB 450 at, what is the weight? 65.3, right? 65.3 kg per meter is used as beam. Class is, or class of section is, plastic. Okay. When the section is used as column, class of section is slender. Okay, so this is very clear from this calculation that this given section you can use for beam, but we cannot use it for column. Okay, the section is safe when it is used as a beam, but the same section we cannot use for column because it is slender. Is it clear, guys?
Yes, ma'am.
Yes, ma'am.
Okay, I want to discuss about the other examples also, like section classification for channel section, angle section. But shall we continue with this lecture, because I have already given you the link in your WhatsApp group for practical, and today also we are going to consider the practical for all the 3 batches combined. So shall I continue with the same link here?
Okay, ma'am.
So actually we have completed our lecture right now, and we will continue with the practical, and in the practical also I'm going to continue this calculation, and later on I will give you the assignment, which is your first assignment as per your term work. Okay, so attendance I will consider at the end only for both theory as well as practical. CR is present? No CR is present. Okay.
Yes, ma'am. Present.
CR कोण आहे? मल्हार
हो मॅम मी
आहेस तू लेक्चरला?
आहे मॅम मी.
बर, तुम्ही आज साधारण 12च्या आसपास.
ओके मॅम.
Okay, so CR, you just put a message in the WhatsApp group that we are continuing with the theory class with the same link for practical also. नाहीतर जे मुलं आता थेरीला ऍबसेंट आहेत ते तिकडे वेट करत बसतील दुसऱ्या लिंकवर. सो जस्ट एक मेसेज टाक व्हॉट्सअप ग्रुप वरती की आपण सेम कंटिन्यू करतोय लिंक प्रॅक्टिकलला सुद्धा, and it is continuous. We are not taking any break. Okay, Mallar?
Yes, ma'am.
Huh. Okay, so this is the first problem which we have solved. We will consider the second problem now. So we will find out now the class for the section ISMC 300 at 35.8 kg per meter. Okay. ISMC, its long form is Indian Standard Medium Weight Channel Section. So now we are calculating the class, or we are finding the class of channel section. So again, I have to write down the various properties of this channel section, its dimension. So if I will go back to the code, again I have to find out the outstanding element of compression flange. So I have to find out B by DF. I have to find out C web of a channel D by TW. So same values I need to calculate now for channel section. So if I will go to the steel table, if I will go to the channel section part or page, here are the channel sections. Let us go to the our required section ISMC 300. So this is ISMC 300, 35.8 kg per meter. Okay, so for this section, we will require now all the same properties BF, TF, D and TW. D means again here we will consider H1. H1 is given on the next page here. You can find out in the diagram also H1. Okay. So tell me these values now for ISMC 300. I will go to the word file now. Tell me BF.
90 mm.
90 mm. Okay. TF.
13.6 mm.
TW.
7.6 mm.
And D, which is nothing but
240.7 mm.
yes. So again, we will find out now the outstanding element of compression flange. Outstanding element of compression flange. Okay. So what is the ratio? Let me go to the code. Outstanding element of compression flange. The ratio is B by TF again. So I will write down B by TF here. Now here, what is B and what is TF? Let us refer into the diagram given in IS 800. So in the IS 800, this is a channel section and this is the B. So for channel section, the full width of flange is to be considered as B, whereas for I section, half width of the flange is considered as B. Again, keep this difference in mind. Okay, so as per this diagram, my B value, which I have to consider for calculation, is equal to BF now, okay, divided by TF. So what is the BF value?
90.
90, na? 90.
Yes,
Divided
ma'am.
by TF is
30.
13.6.
13.6, right?
Yes, ma'am.
So tell me the value.
6.62.
6.62. Let us compare this value with the given limit in the code. So this is outstanding element of compression flange B by TF. The value is coming as 6.62, na?
Yes, ma'am.
Now this value is less than 9.4 epsilon. So the class of the flange is
Plastic.
Plastic.
flange is plastic. Now in case of channel section, when we consider web of a channel, there is no any category as neutral axis at mid depth or axial compression. So channel section, whatever we are using for beam, the same we are using for column. So there is no any separate formula for beam and column. Okay. So web of a channel, there is only one formula, D by TW. So let us find out that value first. So I will simply write down here web of a channel. D by TW. So what are the values?
240.7 divided by 7.6.
240.7 divided by
7.6.
7.6. Okay. What is the value ratio?
31.67.
31.67. Let us go to IS code now. The limiting value is 42 epsilon everywhere. Now see, there is a difference. I'm comparing the two rows now here. The first, if this top row, it is given that not applicable and the value is given as 42 epsilon. So we have to compare with this only. If it is less than 42, it is semi-compact, greater than 42, it is slender. But if you consider web of a channel, all three values are given as 42 epsilon. So if the value is less than 42 epsilon, here the class of the section or the part of the section is always plastic. Okay, if it is greater than 42 epsilon, it will be directly slender. So for web of a channel, we do not have a classification as compact and semi-compact. It will be either plastic or it will be slender only. Okay, so what is our value now? 31, which is less than 42 epsilon. So web is plastic. Okay. So now there is no any separate calculation for the section being used as beam or being used as a column. So whether we are using it as a beam or a column, the class of the section will remain same here for channel section. So the section, I will write down here. What is the overall class you are getting now? Tell me.
Plastic.
Yes. So just write down one statement. The overall class of ISMC 300 at 35.8 kg per meter is plastic. Okay, is it clear? Any doubts in this? Guys,
No, ma'am.
let us move to the next problem, third problem. Let us find out the class of the angle section now. ISA 90 by 60 by 8 mm at 8.9 kg per meter. See, when you write down the description of any particular section, it is always suggested to write down the weight, because we have some sections which are having the same depth. For specifically for I sections or channel section, the depths are same, but the weight are different because the thickness of the various components like flange or web are different, and hence the overall cross section is different, and hence the overall weight is also different. Okay, so even though the depth of the section is same, the weights are different. So for this is especially applicable for I section and channel section. So when you write down I and channel section, don't forget to write down its weight. Angle section, such problem is not there. If you refer the steel table, you will get all this information there. So let us go to the steel table now and we'll find out angle section. So initially on some initial pages only the angle sections are given. Okay, and it is 90 by 60 by 8, it means it is a unequal angle section. So rolled steel unequal angles, you can find out. See here, the first one itself is 90 by 60 by 8, second value. Okay, so this is the ISA, Indian Standard Angle Section, 90 by 60. The size is given as A by B. A is the vertical leg and B is the horizontal leg. Okay. So the thickness is constant for both the legs, 8 mm. So for this, now we will require the different values. Now what values we need to find out? Let us go to the IS code. Now in this IS code, the angle section we have to find out its class. Now the angle section may be used as a axial compression, or it may be used as a beam section. Okay, so we have to use this criteria first: angle compression due to bending. Okay, this is like we are using the angle section as a beam. And second, axial compression. For axial compression, criteria is given here: single angle axial compression. So for both these, we need to do the calculation and we need to find out the class of the section. So we'll consider first the angle or the compression due to bending. Now for compression due to bending, we require these two ratios. What is that? B by T and D by T. So I will simply write down that first axial compression, so the ratio required is B by T. Or I will first write down, wait, the B, D and T value. So my B value, what is my B value? I will go to the steel table here. In steel table, it is given as A and B. Whereas in IS code, IS 800, B and D values are given. So which is my B? Horizontal is B, vertical is D. So let us write down in that fashion only. B is nothing but the horizontal one, so it is 60 mm. D is the vertical one, so it is 90 mm. And T is nothing but the thickness 8 mm. Okay, so just write down these and then we will go for the axial compression. Uh, first case, compression due to bending. We'll consider first case नहीं, first case काय आहे तुमची?
Axial
Compression
compression.
due to bending.
नहीं, first is compression due to bending as per this table, right? So compression due to bending. So the first ratio is B by D, B by T, right? What is given in the code? It is B by T and D by T. So B by T, what is our B value? It is 60, but T is 8 mm.
7.5.
Let us find out D by T also. It is 90 by 8.
11.25.
So let us go to the limiting values. For B by T and D by T, for both the limiting values are same. Okay, our B by T value is coming as 7.5, which is less than 94 epsilon. So I will write down it is less than 9.4 epsilon. And D by T, what is value? 11.25. And here C, 11.25, so it is less than 15.7 epsilon. So this value is less than 15.7 epsilon. Now as per this criteria, the leg, horizontal leg is plastic, right? And as per this criteria, the vertical leg is, what is the class?
Semi-compact.
Semi-compact. Semi-compact. Okay, so under compression due to bending, one leg is in plastic and second leg is in compact, semi-compact state. So what is the overall class in this category? Compression due to bending.
Semi-compact.
Semi-compact.
Correct. So the class of section is semi-compact. I will write down here only. Afterwards, we'll write down one statement. Okay. Then second case, axial compression. What are the criteria now for axial compression? See, B by T, D by T, and B plus D by T. Okay, so we'll just write down these values here. It is B by T, then D by T, and the last one is B plus D by T. The first two values we have already calculated, so I will simply write down the values 7.5, then 11.25, and tell me the third one.
18.75.
Yes, so it is 60 plus 90 divided by 8. Tell me again.
18.75.
18.75. Let us go to the limiting values. See here. Now, as per this row, the first two classes are not applicable. So the section will be either semi-compact or slender. So what is the B by T ratio we are getting?
7.5.
So this value is less than 15.7. So our one leg, now here we cannot say that one leg, second leg, or here, because the third one is combination of the both. So simply we have to consider all the three criteria, and based on that the overall class will be decided. So I will simply write down here, this value is less than 15.7 epsilon. Okay, second value is also less than 15.7 epsilon, because that is the criteria given, right? So if I will check the code, second is also 15.7 and third is 25.25 epsilon. So this value is also less than 25 epsilon. So in all these cases, see here, the first case, it is less than 15.7, so it is plastic. Second is also less than 15, not plastic, semi-compact. Second is also less than 15.7 epsilon, so it is also semi-compact. And third is also less than 25 epsilon, so it is also semi-compact. So all these criteria are getting satisfied for this class, semi-compact. Okay. This is also giving us the same class, semi-compact. So the section under axial compression is semi-compact. So the section is semi-compact. Okay, now if you consider the first criteria, that is when angle section is being used as a beam, the class is semi-compact. When the angle section is being used as a column, then also the class is semi-compact. So the section, the overall class of the section, I will just write down one statement here. The overall class of given section as beam and column is semi-compact. Actually, we do not write down as beam or column. This is just for your understanding. We should write down the clear statement under axial under compression due to bending and under axial compression. These two cases should be written, and for both these cases, the class of the section is semi-compact. So when we consider compression due to bending, when we use a section as beam. When we consider axial compression, when we use it as a column. So just for your understanding, I have written this, but when you write down in examination, write down the full statement. The overall class of given section under compression due to bending is semi-compact, and under axial compression is also semi-compact. Is it clear, guys?
Yes,
Yes,
ma'am.
ma'am.
So I have considered just 3 examples as eye section, channel section, and angle section, because these 3 sections we are widely using, commonly using in practice also for various sections of the steel structures. Okay, so I will stop here only about the examples or numerical examples, and I will show you now the assignment. I have assignment for your practical. I will just open that assignment. All of you are expected to write down that assignment right now. Okay, so I will just open that assignment. Assignment number 1. It is based on the section classification only. So that you have to solve. Is this visible?
Yes, ma'am.
Write down this assignment in your notebook. And yesterday I have given you the code for VLP course. I have uploaded the material. I have not yet uploaded the video lectures. I will upload it by today evening, or by tomorrow you will get all these recorded videos for our lectures also. Okay, and this assignment also I will upload. But right now all of you write down this in your notebook. Next practical turn, obviously I'm going to check this. So I will give you 5 minutes time to write down this assignment. Is it over, guys?
Yes, ma'am.
Okay. Now coming to your batches, I have received the mail from some of the students only. So I just want to confirm those batches. The remaining students. Okay, shall I stop this presentation?
Yes, ma'am.
We will discuss about the batches now or groups developed in A1 batch. I want the name of group members name from A1 batch first, then I will go to A2 and A3. So A1 batch, roll number 1 to 25. How many students from you have formed the groups?
विनय, अक्षता, अनिकेत आणि शार्दूल
Hmm.
हे 4 जणांचे तुम्हाला
मॅम
माहिती.
Just tell me the names. I will type here.
मॅम साहिल
एक मिनिट. विनय औटी.
येस, अक्षता भट,
एक मिनिट. अक्षता भट. हाँ.
शार्दूल चौधरी,
शार्दुल चौधरी. ओके.
अनिकेत जाधव, सिद्धांत भटिवरा.
सिद्धांत
भटिवरा.
ओके. फाइन. हा पहिला ग्रुप आहे. हु इज द ग्रुप लीडर?
विनय औटी.
ओके. नेक्स्ट.
मॅम नेक्स्ट ग्रुप साहिल गुलाने,
हाँ. साहिल
मल्हार
गुलाने,
देशमुख,
मल्हार देशमुख.
अभिजित दुधनकर,
एक मिनिट. हाँ. अभिजीत
दुधनकर,
दुधनकर,
आवेश खान.
आवेश खान. ओके. हु इज द ग्रुप
मैम
लीडर?
साहिल.
ओके. नेक्स्ट.
मैम अंकित गोयल,
हाँ.
तनुष चिद्दरवार,
हाँ.
संग्राम चांदगुडे,
चांदगुडे, राइट?
यस मैम,
हाँ.
मोहित
नेक्स्ट.
बाहेती,
मोहित बाहेती,
यशराज भोसले,
यशराज भोसले. ग्रुप लीडर?
अंकित गोयल मैम.
ओके. All right. Next group. Only 12 students have formed the group yet.
मॅम
हाँ.
रोहन कोळी,
You're from A1 batch?
नो मॅम.
I want for A1 batch first. हे तुम्ही
Okay.
सगळ्यांनी A1 batch च सांगितलं ना आता?
हो मैम.
हो मॅम.
मॅम
हाँ. Wait.
अनुराधा आवारी,
हाँ. ओके. एक मिनिट था. हाँ.
सायली देवरे,
सायली देवरे,
सिद्धेश जगताप,
सिद्धेश जगताप. ओके.
अभिजित जाधव,
अभिजीत जाधव. ग्रुप लीडर?
अभिजित जाधव,
अभिजीत जाधव. ओके. Next group. अब्दी रहमान प्रेझेंट आहे का आज? अब्दी रहमान. ओके. वैभव बंब. रितेश भोसले. तन्मय देशमुख. आता मी फॉर्म करणार ग्रुप तुमचे, बाद झालं, खूप झालं. नाउ आय विल फॉर्म द ग्रुप्स विथ येस.
प्रेझेंट आहे मॅम. आम्ही करतो मॅम ग्रुप.
ग्रुप कुठे फॉर्म झालेत? मी किती दिवस, महिना झालं सांगून.
हा मॅम करतो.
करतो नाही मी, झालं फायनल करून टाकणार मी आता आज. मी डिस्प्ले करेन तुम्हाला, हे मेल करून टाकणार आहे मी ग्रुप फायनल झालेले. मी नाही वाट पाहणार आता यावेळेला. ओके, दिस इज रिगार्डिंग A1 batch. Now coming to the A2 batch. Wait a minute. Yes, A2 batch.
मॅम आरती
हा.
पाटील.
तुझं हे सांग, मिडल नेम सांग.
आरती सतीश पाटील.
Because there are two Aarti Patil na in the class. Okay, next.
ऋतिक लटारे.
Okay.
कांचन पाटील.
Kanchan Patil. Okay.
जयसिंग मोरे.
Jai Singh More. Okay. Who is the group leader?
ऋतिक लटारे.
Okay. Next group.
जयेश काकडे.
Jayesh Kakade. Kakade
यश
na?
शर्मा. यश मॅम काकडे.
हाँ. Yash.
यश शर्मा.
Yash Sharma. Okay.
विजय सिंग पाटील.
Vijay Singh Patil. Okay.
ओंकार खाडे.
Omkar Khade. Group leader.
ओंकार खाडे.
Okay. Next.
मॅडम निशांत नेमाने.
निशांत नेमाने.
आदर्श पाटील.
आदर्श पाटील. हाँ.
ऋषिकेश पवार.
ऋषिकेश पवार. ओके.
ग्रुप लीडर निशांत नेमाने.
ओके. नेक्स्ट.
मॅम प्रज्वल.
एक जण सांगा कोणीतरी. कोण बोलत होता आता?
मॅम प्रज्वल कोल्हे.
प्रज्वल कोल्हे. हाँ. नेक्स्ट.
सर.
6 मिस्टर राइट? हाँ.
नो मॅम तहा.
10. ओके. हाँ. नेक्स्ट.
राविशू धार.
परत सांग.
राविशू धार.
ओके. राविशू धार. हाँ.
श्रुती राठोड.
श्रुती राठोड.
दिव्यानी कोडापे.
दिव्यानी
कोडापे.
ओके. ग्रुप लीडर.
मॅम प्रज्वल कोल्हे.
नेक्स्ट ग्रुप.
मॅम रजनी जांभूळकर.
रजनी जांभूळकर.
नव्या मेरी चेरला.
नव्या. ओके. हाँ.
मेहविश शेख.
ओके.
पंकज परभणे. and Gayatri Shivde.
Gayatri is not there in the class now. Okay. Who is the leader?
Rajni.
Gayatri is present right now in the class. Gayatri Shivde.
No, ma'am, she's not.
She is not supposed to attend the classes, huh? Because she is not on the roll call.
Yeah,
Okay.
ma'am, she hasn't done the RP, I guess.
She hasn't done.
Registration.
She is not supposed because she has not yet cleared her first year. So she is wide now. Okay, next group. Next group.
मॅम
हा
ते एक नाव विसरलो होतो, सिद्धार्थ जाधव माझ्या ग्रुपमध्ये, सेकंड नंबर ग्रुप.
तुझं नाव सांग.
मल्हार देशमुख.
मल्हार देशमुख म्हणजे फर्स्ट बॅच ना, A1.
हो बस, हा मॅम ते सेकंड आहे. सेकंड ग्रुप जो होता, सिद्धार्थ जाधव नाव विसरलो मी.
थांब जरा एक मिनिट, आता मला ते ओपन करू दे. मल्हार देशमुख कुठे आहे? हा, सिद्धार्थ
जाधव.
ठीक आहे. साहिल गुलने तोच ग्रुप ना?
हो मॅम.
हा, ठीक आहे. Okay, some students are still remaining from A2 batch. Now I will
Ma'am.
make their. Yes,
Ma'am, A2 batch, Aryan Solanki and Ujjwal Pasalkar.
only two are there.
Yes, ma'am.
Aryan Solanki,
And Ujjwal Pasalkar.
and I will add one more name in your group, Omkar Kadam. Okay,
Hello,
you
ma'am.
contact him also, or he has formed a group.
I think he has, I don't know.
Right now, I will write down his name in your group only. Later on, if I will not get any mail from Omkar Kadam, then I will include you in your group. Otherwise, if I will get the mail, I will add him according to the mail.
Okay, ma'am.
Why two are only in your batch?
Ma'am, actually, we are going to continue the SGD one group, but ma'am, they are doing like alone. Ma'am, they three are doing differently, so we thought we both will do.
Okay, fine.
Ma'am,
Who
we
is
can.
the group leader?
Ma'am, Aryan Solanki.
कल्पेश पावरा ऍड करा मग त्यामध्ये.
याच ग्रुप मध्ये?
हो, उज्ज्वल पासलकर, आर्यन सोलंकी, कल्पेश पावरा, ओमकार कदम.
कल्पेश पावरा. ओके, ठीक आहे.
हॅलो मॅम.
हा,
मॅम A1 बॅच साठी वैभव बॉम्ब.
थांब जरा. तुझं बॅच कुठलं आहे?
A1 बॅच मॅम.
A1 बॅच.
Yes, ma'am.
हा, वैभव.
बॉम्ब. रितेश भोसले. सुजित जाधव. देशमुख.
काय?
तन्मय देशमुख.
तन्मय देशमुख. बस
हा मॅम.
झाले का? अजून कोण आहे? हु इज द लीडर?
वैभव बॉम्ब.
ठीक आहे. ओके. नाउ A3 batch.
रोहन कोळी.
एक मिनिट थांबा. रोहन कोळी.
साहिल साळुंके.
साहिल साळुंखे.
ऋषिकेश भामोद्रे.
ऋषिकेश भामोद्रे. हाँ.
सौरभ निकम.
Yes. Next.
मोहम्मद अब्दुल्ला सईद.
Who is the group leader?
साहिल साळुंखे.
Okay. Next group.
मैम पार्थ कांचन.
हाँ.
सर्व देवकर.
अथर्व देवकर. हाँ.
दीपक शिंदे.
साई दीपक ना. साई दीपक शिंदे. ओके.
जुनेद शेख.
जुनेद. ओके.
गणेश बोईते.
लीडर.
अथर्व देवकर.
नेक्स्ट.
मैम तनिष्क एब्रॉल.
तनिष
एब्रॉल.
तनिष्क एब्रॉल. ओके.
यश पाटील.
यश पाटील.
रोहन घुले.
रोहन घुले. हाँ.
नीरज जाधव.
नीरज जाधव.
कल्याण गावित.
कल्याणी गावित.
यश पाटील इज द लीडर मैम.
ओके.
मैम
हम्म.
सायली तायडे.
सायली तायडे.
नाजिरा बशीर.
नाझीरा बशीर. ओके.
तेजस काकडे.
तेजस काकडे. हाँ.
एंड आदित्य वडगावे. मैम
लीडर.
सायली तायडे लीडर. सायली तायडे.
ओके. नेक्स्ट ग्रुप.
मॅम आरती संजय पाटील.
आरती संजय पाटील. ओके.
माधवी विचारे.
माधवी. नेक्स्ट.
मानसी तिकटे.
ओके.
रोहित गिरी.
रोहित गिरी.
हो. हेमेंद्र वाणी.
हेमेंद्र वाणी.
ग्रुप लीडर माधवी विचारे.
माधवी.
यस मॅम.
ओके. नेक्स्ट ग्रुप. झाले सगळे. वंडरसन. You're present for lecture, huh? Are you there in the class? Wonderson.
Yes, ma'am.
What is your group?
Ma'am, I haven't found the group. I haven't formed the group yet.
I will distribute now in your. I will form the group then. Okay.
Okay, ma'am. Yes, ma'am.
Because it's too late now.
Yes, ma'am.
Fine. I will give the attendance link now in chat box. Everybody has to give the attendance through that link only. And the same attendance I will count for practical also. Okay. So give your attendance through the link. Same attendance I will consider for practical also.